This conference will now be recorded.
Good evening and good morning, one and all. Sorry for little bit delay. Okay, fine. In our previous class, we were discussing something about data types, okay, and its control strings. Okay, we have seen what actually a data type is. Okay, data type is simply nothing but we will have a rough glance for 2 to 3 minutes and we will start with the new topic. Okay, data type. Data type is simply nothing but it is a way of representing the data what you are passing or what you are entering into the system. Okay, that is what actually a data type is. Okay, if you write the data type I mean, if you declare the data type by using integer or float or char or any other type of data type, system will understand what type of data type you are trying to enter. Okay, but when you want the same data type to be displayed on the screen, you need to use some sort of format specifiers or control strings. Okay, these are called as format specifiers or control strings. Okay, these format specifiers are used when you want to display some sort of or the data type that you have entered to be displayed on the screen. Okay, so we need to use some sort of format specifiers when you want to display the data type what you have defined in the program. Okay, that is what we need to understand here. Okay, we have seen all these things. Okay, how much memory size each data type will occupy, and its value ranges. Sorry, I'm having a little bit throat infection. Sorry again. Okay, we have seen what actually a valid and invalid identifier is. Identifier is simply nothing but the variable what you are declaring in the program. Okay, variable int a is nothing but the variable. Okay, you can declare the variable a simply, or you can declare it like abc. Okay, you can declare it like this. Okay, you can declare it like this by using underscore. Okay, you can declare it in this fashion: a123 means character followed by the number. Okay, you can even declare the variable in the capital letters. Okay, and this is what you have seen here, the same thing. This one is okay, this one is also same here. You can use a number of underscores again in a variable what you are using. That is what an identifier when you are declaring. These are the different valid identifiers actually. There are few methods, there are few ways in which the identifier cannot be declared. Is like the identifier should not start with a numeric value like 10 ABC. Then the identifier, the variable, the identifier should not start with the number. Okay, it must start like this A123. Okay, and this cannot be the identifier. You cannot give a hyphen symbol in between the a variable name or an identifier. Okay, and you cannot give like this. You cannot give double quotes in the identifier. Okay, and you cannot give a space in between a variable or an identifier. You cannot give a parenthesis like a parenthesis and the area and like this and all. You cannot give this percentage symbol. Okay, why? Because we have already seen the format specifies percentage d, percentage f, percentage c, and all. When a percentage is found, the system automatically expects some sort of format specifier, not an identifier. So these sort of identifiers are invalid. Okay, these are valid. Okay, this is what the explanation is actually. We have seen the keywords. Okay, in this we have seen few keywords. When we are going to complete the whole C programming in the last class, we will be covering all the keywords here which are listed here. No need to worry. As of now, we have used only very few. Okay, not few, 2 to 3 or 3 to 4 like that we have used and we have seen. While you are completing this course, you people will be having knowledge on what actually each keyword is and what for we use it. Okay. Next, we have seen this escape codes. We have seen this program also. This program is going to display the data type size or data type's value from which value to which value or its maximum value, how much it will accommodate. Like that. We have seen this one. Addition of two integer numbers. Okay, a plus b, a minus b, a into b, a divided b, like that. Okay. Next, these are like floating calculations. These are like integer calculations. Okay, leave this program. No need to worry. Next topic is like variables and constant. We are going to start this new topic from today. Variables and constant. A variable varying value at runtime duration is called a variable. Means we have seen what actually a variable is. Variable is simply nothing but an identifier. Okay, variable will be having a value. Okay, suppose int a equal to 5. That int a equal to 5 is not constant. If you are going to do some sort of calculations, so that particular value which you have passed into a will be changed. Okay, when you are going to execute the program as per your requirement. So variables varying value at runtime duration is called as a variable. So variable value will not be constant. If the variable's value is constant, then we cannot say that it is a variable having some value. Okay. A variable has a name and type used to hold some data temporarily. You must understand this word temporarily. A variable has a name and a type. So a variable will be having a name and it will be having some type of data that it will be carrying out. For example, int a, we are going to give the name. Okay, that name is a there. Okay, and we have defined the particular a variable as integer data type. So it is of type integer. We use this to hold some data temporarily. Okay. The value of a variable can be altered or modified later at any time in the program. This is what just we discussed. Okay, if we are going to pass some value like int a equal to 5, okay, and if you are going to, okay, we will see this in a small example so that you can understand clearly. I should include std would add h, h, right name, int a equal to 5. Okay, this is what I was discussing. Okay, int a equal to 5. Now what I will do is I will try to add a with some other number. Okay, so a equal to 5 plus 1. Okay, or like this. Just write like this. or write like this, whatever it will be. Printf of value of a is percentage d you can see that. Now I will try to compile this particular program. Alt F9 errors, Control F9. CLR SCR. I will use CLR SCR so that the screen will be cleared while this program is being executed. Value of A is 7. So initially what we have done here is the value of A I have declared it as 5, but later on as per my need, I will write another statement here so that I won't write. If I write, I will get some error. We will see why we get the error in our coming sessions. Not now. If I say that, we will be getting confused now. Okay. Initially, the value of A is 5. Okay. Now, after initializing this value, I am passing some other value to A so that the value initially is going to be changed with the value what I am passing currently. Okay, so that what we are going to do is instead of 5, the value will be getting changed to 7 in the variable A of data type integer. Okay, and what we have done here is we have tried to print the variable A on the screen. Okay, like a printf of by using the printf statement, value of A is percentage d. This percentage d is simply nothing but the format specifier. Okay, and A is the variable what we are going to display on the screen. Okay, fine. Control F9. I'm going to run the program. See, the value of A is 7 here. Now we will put this as a comment. I will run the program now. See, I have put the value A equal to 7 as a comment. So the old value A equal to 5 is alone printed. Itself the A equal to 5 value is only printed. Now I have removed the content. Now I am going to run it. Now the value of A is 7. So the value of a variable is going to be changed or can be altered or modified later any time in the program. Okay, and this is how a declaration of a variable could be. This is what a data type and variable name. Okay, this is what the data type and the variable name. Okay, int abc. This is what the example is. Float cv. Okay, the above declarations abc are of integer type and cve of float type of data types. Okay, in initialization of a value to the variable, we are having two types of initialization. Okay, initialization is simply nothing but passing a value to a variable. Okay, is called as initialization. Means, okay, we will see this. Now, I didn't declare any. Sorry, I have just defined a variable a as integer data type. That's it. I didn't pass any value to the variable a. So what we have done here, we have just declared a variable of data type integer, and we haven't passed or we haven't stored or we haven't moved any value into the variable a. Okay, so what happens here is, now we will compile this program. We will get some result. We will see what actually that result is. Control F. I'm getting some value like minus 28762. I will run it again. I'm getting the same value, or sometimes depending on the compiler, the value is going to display some value, random values whenever you execute the program. Okay, getting random values whenever you execute the program is called as a garbage value. Means if you are not going to pass any value into the variable, and if you try to display that particular variable on the screen, that particular variable will display the garbage value on the screen. I'm repeating. Here what I have done is I have declared variable a of integer data type, and I didn't pass any value. Okay, I didn't pass any value into a. Earlier in the earlier program, you people might have seen like int a equal to 5. Okay, and a equal to 7. I have made int a equal to 7 as a comment. Okay, I will remove it so that people will be clear now. Okay. Int a, okay, I didn't pass any value into the variable a. So the variable a will not be having any value now. And if I try to print the variable a on the screen, if I want to see the value of a of integer data type on the screen without passing any value, the compiler, the system will throw you some value on the screen. That is what compile. This is what the value the system will randomly display on the screen. It will display the value whatever it gets when it is being displayed. So this sort of values are called as a garbage values. Okay. This is what actually I mean, in initialization of a variable, we are having two types of initializations. Okay. The thing what we have just seen, like int a equal to 5 or some other value 1 or 2 or whatever it could be. Okay, giving values into the variable when you are declaring. Okay, int a is called as a declaring. If you are going to pass a value to the variable when you are declaring, okay, it is called as static initialization. So this could be the example. Int a equal to 10, b equal to 20, c equal to 30, like that. So whenever you people are declaring a variable, then and there itself, if you are going to pass the values into the variable, such type of initializations are called as static initializations. Okay. Next, another type of initialization is a dynamic initialization. Dynamic initialization is possible with the statement scanf statement. Okay, now we will see this. Int a equal to a. Okay, now I will write some code here so that you people will understand what I am doing. Enter that variable a. Okay. I will type the program and I will explain the program so that you can understand it clearly. Okay, fine. What we have done here is we have just declared the variable a. Okay, next what we have done is we are trying to enter the value when we are running the program, not in the initialization, not in the declaration part. This is called as a declaration. If I pass values or if I assign value to A here, we call it as the static initialization. Okay, we have just seen the static initialization. Now we are discussing something like dynamic initialization. Dynamic initialization is like a passing the value in the runtime. What is that runtime? Okay, runtime is simply nothing but when you are going to execute the program and on the screen itself when you are going to give the values uh, in a uh, on the way fly manner or during the execution, we call such type of declarations as a dynamic initialization. So that type of initialization is a dynamic initializations. Okay, this is what the declaration part is, and I am raising the request to enter the value variable a. Okay, next we are going to read it. Read it is simply nothing but it is possible with the help of a scanf statement. Again, during the scanf statement, the system must make sure that what type of data type is taking input. So we are giving it as a percentage D and ampersand A. What is this ampersand? Earlier also we have seen that ampersand. What is that ampersand? Now, I will second explain it like this. Okay. Now you people are declaring some variable like int A. Okay, this is what actual int A is. Or simply A. Next, if you pass the value 5 here, okay, the value 5 here, the value 5 here during the runtime, what happens is this is variable A again. During runtime, what happens is the value will be stored here. Inside that variable, the value is going to be stored. Okay, now the difference here is simple. Why we need to use ampersand? Okay, ampersand is going to represent the memory location where that particular variable is saved. Okay, for example, this particular variable A is stored in 256 byte of 1000 GB, 1 TB hard disk. Okay, now if you are going to enter ampersand symbol, that ampersand symbol is going to give you this 256 number to the variable A. So it makes clear what type of variable that you are entering. It gives clear idea that where your variable is stored. Okay, so we need to use an ampersand symbol in scanf statement, and after reading the value of A, we are going to print the value of A. Okay, now we will compile the program. No errors. So I will run the program. See, it is asking me to the enter variable A as listed in the program. I will give the value as a 2. Value of A is 2. So what is happened here is whenever you try to run the program, okay, the variable A will be checked that does it have any value initially. Okay? If not, the system will ask you to enter the variable A, okay, with the help of the scanf statement. Okay. The scanf statement is used to take the input from the user when you are running the program. Okay, after taking the input, the system will automatically display this, will automatically execute this statement and it will display the variable E. Okay, now I will run the program again. Enter the variable A, like 5. The value of A is 5. That is, okay. This is what actually the dynamic initialization is. So this is what the dynamic initialization is. I have told you taking input during the runtime by using scanf statement for only one variable A. You can give n number of variables and you can make the program more bigger one. That is up to you actually. Different types of variables are there in the program. There are mainly two types of programs, local variable and global variable. You people know what is the function in the program. Void main is the function. Void main is the function. This is what the function is. Inside the function, we are going to have some sort of statements and some sort of declarations. Everything will be present here. So, when you are declaring a variable inside the function, we call such type of variables as a local variable. So, int a is a local variable here. Okay. So the variable which you have declared inside the main function is called as a local variable. If you give it like this, what happens? Int a, if I made it come, and if I try to compile, I don't get any error. If I run it, it is again asking me to enter the variable a. I will enter 7. Value of t 7. So both the things like variable declared inside the function and variable declared outside the function is same. The result is same here. The difference is like if you declare the variable inside this function main, this variable is available only if you are going to use it inside this. The statements used inside this function main can access this variable a. Okay, now we will see another example. If I say that, you will get confused. As of now, just understand that the variables declared inside the function is called as a local variable. The variables declared outside the function are called as a global variables. Okay, so this is the example, global variable. Declaring the variable outside the main function is called as a global variable. 1 second, I'm getting an emergency call, please. sorry for the delay. I got an emergency call. Fine. The variables that declared outside the main function are called as the global variables. Okay. So the variable A is of integer data type and the variable B is of float data type. Okay. And here inside the main function, we are again having the two types of variables int C and character D. So we are having totally four variables. A and B variables are of global type variables, whereas C and D is of local type of variable. Okay, so int C and character D will be accessed only by the statements which are present inside the main function. Okay, and integer A and float B is of a global type variable. These two variables A and B can be accessed by any function present in the particular program. So we call the global variables will be available in the entire program. Okay, whereas the local variables is available only for the limited function. Okay. Next, local variable. A, B, and C, the same example. C, D are local variables, A, B are the global variables. We are having another two types of variables called as automatic variables and static variables. We will understand what is this automatic variable. Automatic variables are they are created when the function block is entered and removed. Okay, when the function is terminated, so that particular variable will be removed. It will be out of scope. That particular variable cannot be accessed. Okay, int A and int static int B. So what is happening here is if the control is going the outside the main function, then int A and static int B variables will not be accessed by the compiler. So the variables that are created when the function block is entered, okay, and when they are removed, when the control is going to come out of that particular function, such type of variables are called as automatic variables. Next one is the static variable. The variables which are declared local to a function are called as static variables. And simply, the local variables are simply nothing but the static variables, nothing different. Now, we will see some small program so that you can understand more clearly. We will see a program which can swap the values and swap the values by using three variables. Okay, for example, I am passing I'm declaring two variables a and b, and I am passing some value into a and some value into b. Okay, after executing, the result should be like b value should be in a and a value should be in b. Okay, for example, a equal to x and b equal to y. Okay, so after executing, a value should be y and the b value should be x. Okay, now we will write the program. A equal to 5, B equal to 7. Now I will interchange or exchange these values by using a third variable called as C. So what I can do here is that I will simply exchange the values of A and B by using the help of a third variable. How can I do is like I will write a simple logic. C equal to A. A equal to B. I will explain this logic so that you can understand. D equal to C. Okay. Now what I have done here is initially I have declared A, B and C variables and I have passed 5 value into A and 7 value into B. Okay. So now the value of A is 5 and B is 7. Good. Next. Here what I am doing here is I have written some logic here. That logic is simply nothing but I am exchanging the values of A and B with the help of the extra variable C. So what I am doing here is I am going to pass the value of A to C here, A to C. So A equal to 5 initially. So now the C value will have, right, so that you can understand more here. Value of C is percentage D. Next, A is percentage. I think you people are now in a position to understand why I am giving percentage D here. Okay, hope you are understanding, so I'm not explaining again.
Yes.
Therefore, thank you for replying. Value of B is percentage D, comma D. Value of A and B after exchanging is okay. Okay. Now what I am doing here is I'm going to check in each and every stage what the value of C will be, A will be, and C will be, and finally I'm going to display the result. Okay, value of A and B after exchanging this. Okay, now I will compile the program. I got some error. What is that error? Fine. I have given some extra code. Control F9. I will write it like this so that it will be meaningful. Control F9. Okay, after executing, I will write like this. That C equal to A, that A equal to B, that B equal to C is. This will be more clear for you. So after C equal to A, the value of C is 5. Okay. Initially, the A value is 5 and the B value is 7. So value of C after the first C equal to A is 5. So 5 is moved to C. Next B is moved to A. So it's 7. Okay. Next is after B value is moved, C value is being moved to B. It is like 5. Okay, and finally after exchange of values A and B, after doing this small logic, is like the value of A becomes 7 and the value of B becomes 5. This is what the small program what we can do by using the small logic here. Okay, so what you are doing here is I'm explaining the program again. We are declaring the variable A, B and C. Okay, and I'm passing value 5 into A and value 7 into B. Okay, and A equal to C, and we're writing the logic here. So A value will be moved to C and the B value will be moved to A and C value will be moved to B. Okay, now after exchanging, the value of B will be becoming A and the value of A will be becoming B. So 5, 7 becomes 7. That's it, nothing more than that. Okay, now we are having the same program here without using third variable. We have used A, B and C variables, right? A, B, and C variables. Here we are not using the C variable. We are using only A and B. We are having some other logic, right? Like A equal to A plus B, B equal to A minus B, A equal to A minus. I will write it here again. So A minus B, A equal to A minus B. Okay, so value of A after A plus B is value of B. I'm going much slower for you to understand this logic. Okay, so please try to understand clearly. So value of B will be displayed here. Value of A will be displayed here. See, 5 and 7. I have given the result 5 and 7. A 5, B 7, right? After A plus B into A is 12 and A minus B is 5, the value in B is 5 and the value of A is 7, and finally the result is like 7 and 5. So we are not using the variable C here, okay, in this program. In our early program, we have used C variable and we have written like C equal to A and A equal to B and B equal to C. Now we haven't used the C variable and we have just done some sort of arithmetic operations A plus B, A minus B and A minus B here, and we have moved the values into A, B and A, and I have just displayed the result. That's it. This is what actually the swapping of numbers without using the third variable C. Okay. Next, what is the constant? Okay, shall we start this constant tomorrow? Okay, if I start now, it will extend. Okay, we will see in the next class. Okay, any doubts till now in today's class? Any doubts, please?
No, sir.
Okay then. Okay then. Thank you. We will stop the recording and we will stop the session also. We will see you tomorrow. Okay.